Okay. So you asked what the previous chapter, or what this chapter is called. This chapter is cell membrane or plasma membrane. And like I said, hopefully we're going to draw on a lot of prior knowledge today because we're going to talk about a couple of the classes of biomolecules that we talked about in October. And I'm hoping you remember a little bit about our friends, the lipids and proteins.
That was the open one.
You guys sound so favorable about it.
Wait, what?
Another name for the cell membrane is the plasma membrane. And we call the particular model we have of the cell membrane currently the fluid mosaic model. The fluid mosaic model. So here's your first opportunity to discuss with your table mate what you think that name means. Ready, set, discuss.
I think it means they're liquid particles that fit together and form the cell membrane.
Okay.
A bunch of little pieces kind of moving and coming together to make one bigger thing.
So mosaic, we're totally okay with, right?
Yeah.
We're cool thinking about the mosaics over at church, where we have the Blessed Virgin Mary on one side of the altar at the low altar, and the other low altar we have St. Joseph. And we get it, it's a big picture made out of a bunch of little pieces that are not all the same. Because if they were all the same, it would just be a tiled wall, right? So they have to be different in order to accomplish the goal. Now the goal of those mosaics, because it's sacred art, is to 1, communicate beauty, and 2, to draw you to prayer. So it reaches its goal by being a lot of different pieces. I feel as though you just had a moment.
Yeah.
Y'all good?
Because if they have to be different, it's the hydrophilic little head things, and then it's hydrophobic, and they all interlock to make the fluid mosaic or the cell membrane.
Fluid tends to be the one that we have a little bit of a struggle with, because usually when we think fluid, we think liquids, right? In this case, don't think of fluid as a liquid. When we say that a ballet dancer's movements are fluid, we don't mean that they look like a bucket of water.
This is an adjective, not a noun.
Yes. In this instance, fluid is an adjective and not a noun. It describes the membrane flexibility. It's flexible and kind of has a little wiggle room. Its movements aren't jerky, it's not rigid, but it's soft, it's fluid. Now you're with me. Life is good.
So I start making a beat.
Where's the anti-base when you need it?
Oh my.
I will be done entertaining myself now.
No, it's not any
So, I will tell you, this particular mosaic that you are looking at is a slightly oversimplified version. There are other pieces that fit in there, but the most important piece is the one that's represented here. So, this is another moment for discussion for you guys. We're going to pause, discuss together, or at least see if you can't, shake a few things loose from that chapter. What is the small piece here? What is this made out of? Ready, set, to... What is that little piece called? A specific kind of lipid. It's a phospholipid. So we can see here one layer of phospholipids and another layer of phospholipids. So, God bless you.
Aw, yeah.
So,
We do the red, please.
here's one phospholipid right there. And remember, the phospholipids have 3 different parts. 1 glycerol head, Glycerol, 1 glycerol head, and 2 fatty acid tails.
Wait, can you spell glycerol?
Sure, Glycerol.
Who's that again?
Glycerol. So it has a glycerol head and 2 fatty acid tails, and I'll tell you there's a distinct difference in their fatty acid tails. One is saturated and one is unsaturated. Now, double bonus, not only when there are fewer people in the room, it's an easier crowd. Double bonus for us, though, it means there's enough of you, or so few of you, or the correct number of you, or the critical mass of you, or however you look at it, we can all pretend to be a phospholipid, and we'll see why it's important that one fatty acid tail is saturated and one is unsaturated. So this is what you're going to end up doing. Okay. So what we concluded was the fact that the glycerol head and fatty acid tails, we have 2 different fatty acid tails, one saturated and one unsaturated, because it serves a function. It makes the membrane the perfect density or the perfect closeness of packing, where it lets some stuff through, but not everything. That idea of some things passing through, but not others, is called semi-permeable. So the differences in our fatty acid tails allows the membrane to be semi-permeable. Semi means kinda, sorta, half, semicircle, semi-soft. You're like, semi-soft? Come on, cheeses. When was the last time you guys had a good cheese? Semi-soft cheese. Semi means half or partially. Permeable, able to be permeated. Something can pass through it. Here's your next opportunity for discussion with your partner. Think of things in real life that are semi-permeable. Examples of things you encounter that allow some things through, but not others. Semi-permeable. What kinds of things can you guys think of that are semi-permeable?
Fabric.
Fabric?
I said like a filter.
Filters?
Sponges?
Sponges?
Security guard?
Security guard? Do you possess a donut? Isn't that how you get
Yes.
through?
I got it.
Drains? What?
Ubai, you know, but like do stuff like furniture, like
Also an adoption.
Skin? How about garbage bags? Keep the garbage in, but somehow outside of the bag it still smells like garbage. Agreed?
Screen door, I can get through it, but if I walk into it, I don't think so.
A screen door. That is absolutely true. Truthfully, this always brings up the fond memory I have of my sister's dog. So I think I told you my sister has basset hounds and they're dumb. So I told you guys that.
Wait, aren't they, is it?
Is much like your cell membrane, because what I showed you before is too simple. Too simple. Instead, what the cell membrane actually looks like is this. So it's not really just phospholipids. It's phospholipids with a lot of other parts. And those parts act as special passageways for other items. And there's specific passages for a specific item. Just like that toy you had when you were a kid where the star went in the star and the moon went in the moon. Only specific shaped chemicals can make it through specific transporters. So they're unique. I'm going to give you a moment to sketch this into your notes before I yammer on about it. The first thing I will point out here is the cholesterol. That'll be the first thing we talk about because we've already talked about the phospholipids, and those are the next things that kind of embed themselves. And they have a great deal to do with membrane fluidity. So I'm going to ask you about bacon. Why? Because it's Friday and we're supposed to be doing penance. So since we can't have it, let's talk about bacon. What happens when you heat up bacon fat? What happens to the bacon fat? It goes from what state of matter to what state of matter?
Solid.
Solid to a liquid. And when we let the bacon fat cool off, what happens? It hardens, goes back to solid state. This is true of all lipids, right? All lipids, if heated to a certain temperature, will become liquid. And if cooled, will then become solid. Especially animal fats. Well, cell membranes are mostly fat. So if you cool off a cell membrane too much, it's going to become what? Made of fat. If you cool it, it becomes a solid. It settles really close together. It gets solid. And you remember that whole like fluid as an adjective, not a noun thing? It's no longer fluid because it's settled close together because of temperature. If you heat it up too much, it dissolves into a liquid. It falls apart. For the purposes of what a cell membrane is supposed to do, that's bad. Like, that's undesirable. So there's something that's actually stuck into that cell membrane to prevent that
Good
from
afternoon,
happening.
DC.
That's cholesterol. Let's pray.
This is Mr. Horst.